Hey, number 10, it worked both ways, right? So therefore, yes, they were inverses. Number 18, you were trying to do the doubly augmented thing. Doubly augmented, reviewing your row operations. Remember, section 8.1, I think, had one of the hardest by hand types of problems in the whole chapter. So even just in this section of inverses, reviewing the row operations is a really helpful thing to do. Really helpful thing to do. They had to multiply everything by a fourth and then go ahead and get their 0 and then go ahead and, hey, they got their identity, which meant the inverse existed, and there he was. Number 20, though. You could not have done the ABCD method. That would have been brutal. But row reducing, yeah, it took a while. But it wasn't impossible. It was like a section 8.1 problem. Yes, you were able to get to the identity. And remember, as you tear down the one, you build up the other. The inverse ended up being that final matrix of negative 13, 6, 4, 12, negative 5, negative 3, negative 5, 2, 1. And in your homework, guys, yes, you could have been using, wait, we did this at the end of yesterday. Isn't there a cool button on your calculator that does inverses? Yeah, where is it? Ooh, it must be under the matrix menu. Everything's under the matrix menu. REF, RREF. No, it's not. It's just that little button right there underneath math, the little negative 1. Could you have been using that to check any inverses you were finding and make sure you were right? Ah, see the little negative 1, x to the negative 1 underneath the math? If you get a matrix, and remember you have to go second that button to go get a matrix, like matrix A. But as soon as you name a matrix, put the negative 1, it'll give you the inverse if it exists. Oh, struggle. Yeah. If you get to use this, just use the negative 1 button. So much easier. But wait, what did I just say? If we get to. Remember how I said there's a calculator, non-calculator part? But, is it good to know how to use this? Oh, definitely. And then, guys, like the one I just did, it was one I made up yesterday. I got all these nasty decimals. How do we make it nicer? Even with matrices, you can do math frac, right? Math fraction, and then, it's still kind of gross, but oh well. At least it's nicer, yeah. And it matches up with the back of the book better. Why was I saying that? Because technically you could have checked on your calculator, and now it would have taken time, extra time to put in the matrix, but you could have checked all your evens even before today. Number 40 was nasty. Who wants to row reduce something with nasty fractions? Even the ABCD with nasty fractions, I mean, it could have been done, but they were like, you know what, I think the formula's best. It's a 2 by 2, and the formula works with a 2 by 2, sadly, only with a 2 by 2. But they use the formula being, remember, yes, you switch the main, like Matthew was saying yesterday, you switch these two, 8/9 and negative 1/4. You switch the signs, or you do the opposite numbers of 9/4 and 5/3 to be negatives. But then in front, remember, you need 1 over the determinant, 1 over AD minus BC. They did that totally off to the side because they were like, ugh, these fractions are gross. They ended up with a fraction after getting common denominators of negative 143 over 36. That's reduced, the best you can do. All you had to do was 1 over that, multiply by the reciprocal, bring that puppy in. And I know it's gross, but that's your determinant. Sorry, that's your inverse. I'm using improper vocab. Sorry, guys. That's your inverse. And it was probably the easiest way by hand. The other methods would have been gross with these values. Especially looking at the answers, like, ugh. Down here, number 50, even though this one wasn't as gross as the one up above, the numbers are still big. It might be easier to do all of it all at once in the formula. 1 over AD minus BC. Switch the main, opposite, the opposite. But this is one of those where you were doing, and some of you might have gotten stuck on this one. At the end of yesterday, remember how I said, how am I so confused right now? Where's section? We're missing a lot of pages, aren't we? Wow, what happened to my notes yesterday? Well, it's not very helpful for me to show you what we're missing, because it's not there. Let me see if it got saved on the PDFs. Somehow it got deleted. There was something where I had a times x equals b. It was right towards the end of class. For some reason, all those slides went away. Oh, dear. Let's see. But anyway, guys, that's what's going on in number 50 is that you're solving an equation. And so to solve an equation, you have to multiply the answers by the inverse. That's another alternate way. Rather than substitution, rather than elimination, rather than RREF. I'm not saying it's better. I'm just saying it's an alternate way. Oh, this has all the pages. Huh. All right, well. There he is, this one. It was another way of solving an equation. That's what that problem is that we're just now grading said to do. If we find this guy's inverse, we can multiply him by those little baby answers, and we get the variables. So anyway, that's what's going on. I just wanted to show you guys. The directions might have been a little weird for you. But all of it was to get to 1/2 and 1/3, which I know could have been found other ways. We're just using the idea of an inverse. All right. With that, we've gotten to the end of the evens, but do you guys have any other questions on the odds or the other evens that you would like to ask? Joe? 71. Anything else besides 71? Jason? 23. We'll start there. Anything else? On 70? Okay, so let's start on 20. Sorry, Jason, 23? What was it, Jason? 21. Jason, what problem? Thank you. All right, so number 23, we are trying to find the inverse. Oh, why is 23 so gross? It's a 4x4. That's ridiculous, except what do you notice that's very strange about this 4x4? Look at all those zeros. What? It's like they're trying to give me an easy one, but I wonder how it's easy. Guys, you couldn't do the A, B, C, D, E, F. No, we're not doing that. That's ridiculous. You'd have 4 different 4x4 equations. Nope. We're not going to do the formula because that only works for a 2x2, and this is way bigger. But we can do the doubly augmented. Now, I know that's gross, except remember how we just said there are tons of zeros? I wonder if that makes it easier. We work by columns, right, cool kids? So as we work by columns, don't we need to get the 1 first? And how do we get the 1? Don't we multiply him? Yeah. By the reciprocal, or divide by him, we would multiply by negative 1/8. And what would happen to this entire row? Well, 1, but times 0, it stays the same, which is what I want anyway. And then I would have to do negative 1/8 times him, right? Now, normally, we would rewrite these guys because we can't touch them yet, and we would get zeros. But, guys, what do we already have? Oh. So, why am I rewriting this guy as he is? He doesn't have to change. I already have. Maybe I can do my columns, like, all at once? So this guy already has 0, so if I rewrite it, he's fine. Second column, that's a 1, I'm good, and zeros. Well, then he's good. Third column, what do I need? Okay, so let's do 1/4. Hey, I like this kind of row reducing, don't you guys? Times 0, times 0, times 4, times 0, times 0, times 0, times 1. Let's see if we can finish our whole row reducing in one matrix, because now all I need is, got him, coach, because times 0, times 0, times 0, times negative 5 is our 1, times 0, times 0, times 0, times 1 is negative 1/5. Whoo! That could have been so much worse, but it was so nice. Does that make sense though, Jason? Thank goodness it was that nice too, huh? So the inverse matrix, remember, is who was built on the other side. So this guy right here. And then, Joe, you said number 70. Okay. And then, Priscilla, did you say 70? Okay, 71. A florist is creating, it sounds like there's a hidden system of equations, doesn't it? I see all these different prices. I'm pretty sure I have some X's, Y's, and Z's. What do you guys think? What do we got? Roses, lilies, irises. I have 3 unknowns. I'm guessing how many of each. So if I make the roses X, if I make the lilies Y, and I make the irises Z, what can I set up? Yeah, because I see $2.50 times X, $4 times Y, $2 times Z. The customer has a budget of $300. That's the maximum amount, which is actually quite low for, oh yeah. Although maybe this is just for the reception. Huh. Well, these totals are only for the reception, but yeah, if 300 for, wow, that'd be really low. Allocated for the centerpieces, allocated for the centerpieces, there we go. And wants each centerpiece to contain 12 flowers. So however many, I'm going to put this up because I don't like that one being my first equation. So however many roses plus however many lilies plus however many irises needs to be 120. Ooh, right? Because each centerpiece has 12, and then we have 10 centerpieces. Okay, so 120 flowers total. Although a good florist would buy quite a few more because some of them get damaged. I have a friend that does wedding flowers. Anyway, coming back. What else? Because we have 3 variables. This isn't enough. We need one more. Oh, twice as many roses as the number of irises and lilies combined. Does that make sense? The number of roses is twice as many irises and lilies combined. Does that make sense? Now, I wouldn't leave it like that, right? Because to make a matrix, don't we need everything all nice and like organized and in columns? So I can use my 1 and 1 and 1 and 120, and I can use my 2.5 and my 4 and 2 and 300, but don't I need to move all this to one side? So how does 1 and -2 and -2 and 0 sound? Because I could go ahead and rewrite this to be x equals, oh, because I'm on the other program, 2y plus 2z, and I would subtract the 2y, subtract the 2z, and have a 0 left. Ha-ha! 3 equations, 3 unknowns. Right, a system of linear equations that represents, well, sweet, I had that way up here. Even though it wasn't nice and organized, it was a system. That's letter A. Letter B, write a matrix. Oh, it said matrix equation. Okay, matrix equation, we can make this matrix A. And we could do, let's see. They wanted it to be all nice and pretty. So this could be matrix A times our unknown matrix X could be matrix B. We could do that. And then our unknown matrix, we haven't defined him yet. He would be our X and our Y and our Z, if that helps. So that's technically following the directions. So we have A times the unknowns equals B. And then letter C says solve using an inverse matrix. Hey, guys, it's a word problem, right? So word problems I usually let you use. And we just talked about how to do the inverse in the calculator. So can't I say that my X matrix, which is my X and Y and Z, will be, can't we throw in A to our calculator and do the inverse and then do times B? Nice. So you would throw in your A matrix, 1, 1, 1, 2.5, 4, 2, 1, -2, -2. That would be my A. You would throw in your B to be 120, 300, and 0. And then in your home screen, you would do A with the little -1 from the button underneath math times B, and you should be able to solve for your final solutions of, I could look it up real fast. You guys can double check and make sure it works, but I think our system is good. What was it, Matthew? 80, 10, and 30. Do you guys agree, those of you that checked it? Yeah. 80 is X, 10 is Y, and 30 is Z. It's over here somewhere. You guys can't see it, but I got it. 80, 10, and 3. 30. Sorry, 80, 10, and 30. All right, cool kids. That makes sense, kind of, yeah? The hardest part is usually setting up. But are you guys at least kind of getting a feel for, it's okay, we're reading, figuring out what our variables are, and then just setting up relationships, pretty much, right? Why would someone want twice as many roses as irises and lilies combined? Anybody who knows anything about flowers, maybe that makes a little bit of sense, to have like a dominant flower as opposed to, and the other ones are just kind of like a complement. Or anyway, it's kind of actually a very practical problem. Although maybe some of you guys realize that once people specialize in things like this, they kind of just get a feel for, oh, I should get like this many dozen extra, and I should probably, but there is some calculation that goes into, especially when people have budgets for anything, for food, for flowers, for when you're having to think through all of this. And when there's something like flowers, where there's flowers that are definitely way more expensive than others, there's a lot to consider. All right, here we go. My notes are strangely very rearranged. So let me get back to section 8.4 that we're trying to figure out. Let me freeze that screen for one moment. I think maybe I just got a page from the future notes in the wrong place. Let me see if maybe by moving him everything gets better. Yeah. There we go. I found the notes. Just a page got put out of order. There we go. So these are the notes that we took yesterday. Got it. And now we're in section 8.4. Aha! And we're ready to go. Cool. We know the beginning of 8.4 already. And I used the name yesterday, and I even used a little bit of the notation. DET. P.S. You had your calculators like just a second ago, right? If you guys go into your matrix menu, remember how the inverse button wasn't in there. It's like way back on the home screen, and it's just a button underneath the math. But if you go into matrix math, where the REF was and where the RREF was, or is, I should say, what's the very first matrix math option? DET, which now we know stands for determinant. DET. It can be done in your calculator very quickly just by using that operation. As always, we want to be able to know how and be able to use our calculators. They are a tool. But we don't want to be completely dependent on them. So DET, that's one way of saying determinant. Also, I know it's kind of awkward, but absolute value. And guys, we saw absolute value with matrices also. Absolute value was used to stand for magnitude of vectors. Did I say that wrong? Absolute value was used for vectors also. It stood for magnitude. And complex numbers stood for magnitude, kind of. For matrices, though, the absolute value around a capital letter in context of meaning a matrix is determinant. And then here's another kind of awkward way of showing it, but it's still true. If a matrix ever has, instead of brackets, if it has absolute values, it also means determinant. So all three of those mean the exact same thing. If it's a 2 by 2, you would just do what I would say. Main, multiplying the main, minus the opposite, or as one year used it, main opposite. They were super lazy. Didn't even want to say the word minus. Anyway, main minus the opposite. But that only works for 2 by 2. Now, ironically, the 2 by 2 isn't even the easiest determinant. Easiest to the 1 by 1. Because a 1 by 1, it's just itself. Oh, well, that's cool. A 1 by 1, the determinant is actually itself. But just getting used to this notation, that could also be written as the absolute value of matrix A, or the absolute value of -2, which is kind of awkward. And so we don't usually write the absolute value around a 1 by 1, because there's actually a meaning with absolute value around a single number. So we probably wouldn't use that notation, but you still could use the absolute value around matrix A. But just a reminder, absolute value doesn't mean make them all positive. It means determinant. So we're not even going to say absolute value past this point now that you've learned the notation. So this is determinant of A, this is determinant of A, and technically the other one's determinant of A, but it's just way too confusing to write of any matrix that's a 1 by 1. So 1 by 1's easy cheesy. It's itself. 3 by 3s are higher. Well, it's a little bit harder. 3 by 3s are higher. It's a little bit harder. Okay, my notes are out of order. Oh, I thought I fixed it. Sorry, guys. This was totally one that we did yesterday. Okay, pull him up. That was one we did yesterday. Pull him up. What on earth? Didn't we do that one? This is like from 2 sections ago. Okay. Let's just pause there. Let me freeze the screen as you guys play around with these 2x2s. Shouldn't be bad, main minus opposite. You were doing it sometimes last night in homework when finding an inverse. Let me just pause the video for 1 sec as I try to figure out why my notes, yeah, equaled 7 because, except my marker's not working now, 4 minus -3, yeah, ended up just being addition. The next one ended up being, because we just had 4 minus 4. Then the last one ended up being -3, making sure that you guys properly did the order of 0, minus, and then a little fraction to make life exciting, but 2 over 2 reduced. And so 0 minus 3. Out of these 3 determinants, which one or ones is singular? The one with a 0, which is B. Yeah. So if I was to add in the label singular, I would do that with letter B. Remember, singular means non-invertible. Inverse doesn't exist because of the formula you saw last night. 1 over AD minus BC would not exist with a 0. So quick reminder about that. Sorry, guys. Now let me go over to the other notes that are in the right order. Goodness. Let's go find the page you guys actually need. Aha! Nope, we already did that one. There we go. So what do we do when we have somebody that's a 3x3? I'm actually going to unveil, there we go, unveil what's there. Let me give you a little bit of time to write this down. I want you guys to go ahead and write the beginning matrix. Our job, our goal, is to find this guy's determinant. But if you notice, all I've done is rewritten this guy 3 times, right? All I've done is rewritten him 3 times. And I want you guys to do what I did as far as a dotted circle and then crossing off, a dotted circle and then crossing off. But I have not shown the last one. I want you to follow the pattern in the third one. So get down the original matrix, get down the 3 repetitions. And then write down the first 2 things that have happened. Try to follow the pattern in the third. And then I'll show you how to use all of what you see in the last one. Who'd you circle with the dotted circle? Got him. And then crossed out. Ah, is that one way of describing what's going on? Cross off his row and his column? Okay. So the pattern is taking each entry in a row. We took each one, the first and the second and the third in a row, and crossing off the corresponding row and column for whatever we're dealing with. Let me show you, without even writing down the formula, without even talking about all this spiffy vocabulary of what we're about to do, let me just show you how the process works, and then I'll try to explain to you what all the pieces are called. The determinant of A, we can't just do main minus opposite. Number 1, because there are lots of other entries, and number 2, it only technically works for a 2x2. But one way of thinking about it is if you did main minus opposite, we would leave some guys out. So what's the way to solve for the determinant of A? We take each number in a row or a column. We just choose one. 1 row, 1 column. You can choose any row, any column. And you take that value in front and you write down the determinant of whatever remains. And you're going to multiply the 2. And technically in front of each entry, there's going to be a particular sign, either a positive or a negative, and we'll explain where those come from in just a second. But in this case, in this one, we're going to have a positive. Whatever one entry has, the next entry is going to have the opposite sign in front of, well, I guess we can think of adding, but then we're going to have the opposite sign in front of whatever coefficient, whatever entry we have. So somehow these are going to be flipping. We're still taking whatever is circled, and we're still writing down the determinant of whatever is left when ignoring the row column of whatever entry we're dealing with. And once again, as we go on to the next, our signs will alternate yet again as far as being multiplied by whatever entry we're dealing with, writing the determinant of whatever is left. And if you notice, I've just broken down the question of what's the determinant of a 3 by 3 to 3 determinants of 2 by 2s. Now, there's more to the formula than that, but at least it's a whole lot easier than it was a second ago. Now, first of all, it actually is super, super nice whenever you get to pick a row or a column with a 0, because what's going to happen if we multiply positive or negative anything by 0? Oh, sweet. Well, that whole thing is just going to end up being 0. But then for everybody else, I'm adding a negative times 2, which is, okay, fine, minus 2. But for everybody else, I actually have to do the operation, and the operation is find the determinant. So what's the determinant? Have we gotten good at them yet of this next matrix? 3 minus 8. And you could go ahead and get a negative 5. If you're not super confident in your mental math, slow it down a little bit. Just write 3 minus 8. Then we'll go to the next one, which once again is not 0. So we're going to have plus a positive 1. And my determinant is going to be? Yeah, some of you guys are already doing it like mental math style. That's great. But once again, if we're slowing it down, it'd be 0 minus a negative 4. At this point, all we have to do is finish this up. To get 0, minus 2 times a negative 5, plus 1 times a positive 4, right? So we end up with 10 plus 4 is 14. Guys, see if you can get that DET operation in your calculator to work. To double check us and make sure we're right. So throwing in matrix A at the beginning, going to your home screen and using DET from the first option in the matrix math menu. Check it and see if we're right before we go talking about what we just did. Yeah. Yeah. It does have to do with the positive, negative, positive. You can almost think of it, Matthew, like the mains were all positive and the opposites, like with the 2 by 2s. It's kind of following the same pattern. As far as if we were to go main, it was positive, opposite was opposite. And think if you have a bigger matrix, it would actually keep going and keep going. Now there's a shortcut to that for a 3 by 3, but for any bigger matrix, thinking about continuing on with that pattern doesn't actually work. But that kind of gives you the idea of why we're having to go back and forth. Does that make sense? Yeah. Oh no, this method actually works. This method actually does work for any size matrix. I'm showing you the best one, the most general one. There is a trick for 3 by 3s. Matthew was asking about like why the signs are flipping, if that has anything to do with, and I was like, well, before when we went across, like a 2 by 2, we went across and it kept the sign. It was a positive times whatever that was. And then it was a minus. It was an opposite of whatever that was. You can kind of think of, oh, the 0 stays, the 2 flips. Or even the 0 stays, the 3 flips. And if we were to keep going, 0 stays, 2 flips, that stays. There's kind of a trick to do a 3 by 3 that some might think are faster. But it only works for 3 by 3s. That's why I'm starting here. Jason. You're thinking of 4 by 4, right? Yeah, 4 by 4. Well, the 4 by 4, you're exactly right. The 4 by 4 would get broken down to 4 determinants of 3 by 3s, and each of the 3 by 3s would get broken down into 3 determinants of 2 by 2s. It sounds awful, unless there are lots of zeros, and then it gets a lot easier. So hang in there. What did we just do? What we just did is basically this formula. Now, guys, you don't need to memorize this whole thing. Just check it out, and then write down what's important. A determinant of a square matrix of any size. Okay, of any size, not just 2 by 2s, but 2 by 2s or greater. The determinant of a square matrix of any size can be found by adding together, like you just saw me do, for any one row or column. For any one, we're only doing one. And that takes into account the entire matrix. For any one row or column, maybe depending on how many zeros are in a said row or column as to who you choose, we're multiplying the entries, which we've gotten used to this notation, hopefully, A11, A12, A13. They're choosing the first row in this formula, but they could have chosen any row, any column. They're just choosing the first row. Every entry in that row times what they call, okay, here's a new vocab term, right? Times a cofactor. So think about what we just did. We just took the entry, like every single circled number, so every entry, A11, A12, A13, that was written in front. And then, well, what were the cofactors? What were we writing next to those entries, guys? Determinant of whatever was left. Does that make sense? So cofactors, they must be the guys that are left. Almost. The other thing that we're missing is the positive, negative thing. So cofactors must have something to do with the determinant of whatever's left with positives and negatives. Here's another new term, expanding by cofactors. So out of this page, this is pretty important, where the capital C stands for cofactors, and the whole process is called cofactors. What we didn't get to do was talk about like the special vocabulary of who these guys are. They're called minors, and that goes from there. But the cool thing is, kiddos, is if you can follow the pattern, you can actually do basically all of homework except for the technical stuff, as far as like, if they ask me for a cofactor or a minor, I might not know what that is. Homework's going to be due Friday. But we do need to finish before partying tomorrow, section 8, for example. Sound good? All right, bye guys, see you later. Don't forget, in honor of pi, circular or maybe triangular.